Welcome back to McMaster Start Coding. My name is Gerline and I'm a mentor. In Lesson 6 today, we will explore how to achieve 2.5D perspective within our pictures and our animations. As always, we will begin by heading to macoutreach.rocks using Google Chrome. We will put in our username and our password, and we will be sure to use capitals wherever we need them. In this lesson, we will be working in a new slot. It's the third slot on the second row, and it's called the Puppet Show slot. We can head to any number slot. As before, the code we write will be saved in whichever slot we work in. When you enter a new slot, there will be default code. Let's hit compile to see what this code generates. At first glance, the code looks pretty similar to what we've seen in previous lessons, but there are a few key differences. To begin, instead of saying My Shapes Model, it says My Layers Model. This is because, in the Puppet Show slot, all shapes are converted into layers. Layers are what allow us to achieve 2.5D perspective. The first shape in our list is a red circle with a radius of 40. We also have a line of code that says, with depth 300. This is the line of code that converts our circle shape into a layer. The number corresponds to the layer's position in the z-axis, which is the axis that points into the screen. Previously, we have worked with the x-axis, which goes right and left, and the y-axis, which goes up and down. The second thing in our list is a yellow circle with a radius of 50. The circle is moved to 50, 0, and has a depth of 500. Let's make both of our circles have a radius of 40. When I hit compile, you may notice that the red circle looks bigger than the yellow circle, even though both circles have the same radius. This is because the red circle has a smaller depth compared to the yellow circle. It's like the yellow circle is farther away from us than the red. We see this effect in real life too. If you have two identical objects and you place one close to you and the other far away, the one close to you will seem like it's bigger, even though it's not. Another thing you may notice is that the red circle overlaps the yellow circle. In previous lessons, we learned that a shape in a list will overlap previously listed shapes. In the Puppet Show slot, we must consider relative depth before we consider list order. A smaller depth in the red circle means it will overlap the yellow circle. Only when we have equal depth, the list order matters. Let's make both layers have a depth of 300. Now the list order is considered and the yellow circle overlaps the red. Let's move on to the next example. We will create an animated fish scenery. There is some code here that has been prepared for the lesson. This code uses knowledge that we gained in previous lessons. Let's do a quick overview. To begin, we have a group named seaweed, and this group is a function of time. So every time we call this group in our MyLayers model, it must be followed by a value for time. Then we have a group called fish, which is a function of color. At the bottom, I have pasted the repeat functions from Lesson 5. These functions are built into the animation slots, but not the Puppet Show slot, so we must paste them here if we wish to use them. You can copy and paste them from the animation slots to here. Repetitive motion will be useful in the creation of the scenery as it will allow fish to start from one side of the screen and swim to the other side. Then, the fish will repeat this movement. If we used sine or cosine with model.time, our fish would swim back and forth, but half the time, the fish would be swimming backwards. We want our fish to repeat their movement over a certain distance, which is the screen width, not after a certain amount of time. So, we will use the repeat distance function today. Let's begin our scenery by adding in a background made up of water and a seabed. We will use a large light blue square for the water. We will give this square a depth of 500. We will also use a large light yellow square for our seabed, and we will move it down so that it doesn't totally overlap the water. Again, we'll use a depth of 500. Next, we will add in our fish. Our first fish will be orange. It will move in the x direction according to the repeat distance function. We used this function in Lesson 5, but let's do a quick review. To use this function, we must write the function name followed by inputs for speed, distance, start position, and time, in that order. For our orange fish, let's use a speed of 20, a distance of 400, and a start position of -175. And then for time, we'll use model.time. In the y direction, our fish will stay at 0. Remember, we also must give our fish a depth. For depth, we will use 100. Our next fish will be pink. Again, this fish will move in the x direction according to the repeat distance function. Let's use a speed of 20, a distance of 400, and a start position of -175. For time, again we will use model.time. In the y direction, let's put this fish at a point of 30. We will give this fish a depth of 200. Let's add our last fish. This fish will be blue. Let's make this fish swim from the right side of the screen to the left, unlike the others. Let's first mirror our fish in the x direction so that it faces the correct way. We will use our repeat distance function in the exact same way, but we must use a negative speed value so that our fish swims in the intended direction. This fish will have a depth of 300. Time for a discussion checkpoint. Question number 1. Why does the orange fish look larger than the rest? Question number 2. All fish are swimming at a speed of 20. Why does the orange fish seem to be swimming the fastest, followed by the pink fish, then the blue fish? I will play the animation for 10 seconds before I reveal the answer. Pause the video now if you need more time to think. The answer to the first question can be understood by referencing the previous circle example. Although all the fish are the same size, the fish that is closest to us, or the fish with the smallest depth, will seem bigger than the fish with the larger depth. Our orange fish looks biggest, followed by the pink, then the blue. Their depth are 100, 200, and 300 respectively. The answer to the second question is similar. When we have identical objects moving at the same speed, the object that is farther away from us will seem like it's moving slower than the object that's closer to us. You can see this effect in real life. For example, you may have noticed that cars driving far away seem to be moving very slowly, even when they're on a highway where the speed limit is quite high. Let's add our seaweed into the scenery. Our seaweed is a function of time, so remember that each time we use our seaweed group in MyLayers model, it must be followed by model.time. We will move the first piece of seaweed to 50, -130, and we will give it a depth of 300. Our second piece of seaweed will be placed at -50, -130, and it will have a depth of 200. Now we have our fish scenery. The fish are weaving in and out of the seaweed pieces. We can understand how the fish interact with the seaweed based on their relative depth, and if they have equal depth, the order in which they appear in the list. The orange fish swims in front of both pieces of seaweed because it has a smaller depth than both pieces. The pink fish swims in front of the right piece of seaweed because it has a smaller depth. It swims behind the left piece of seaweed because both have an equal depth, and the pink fish is listed first in MyLayers model. The blue fish swims behind the left piece of seaweed because it has a larger depth, and it swims behind the right piece of seaweed because both have equal depth, but the blue fish appears first in the list. Let's move on to the final example. In this example, we will create a scenery in which a planet orbits around the Sun. The Sun will be made up of a yellow circle with a radius of 40 and a depth of 300. Our planet will be made up of an orange circle with a radius of 20. In order to create a horizontal orbit-like movement, we must animate our planet in the x and the z directions. To animate in the x direction, we can use sine or cosine with model.time in the x component of the move command. In the y direction, we will keep our planet at 0. To animate in the z direction, we will animate the depth. We learned in Lesson 3 that to create circular motion, two directions have to be animated, one according to cosine and the other sine. Both directions must have the same span and speed of motion. We will apply that knowledge here, except we will animate the x and z directions instead of the x and y directions. Our planet is orbiting around a point of 0, 0. If we want our planet to orbit around the Sun, it must have an orbit with a span of 100 around a point with depth 300. So let's make that change. There are an infinite number of motions you can make considering that you may animate movement in 3 different directions. Time for discussion checkpoint number 2. How could we change the code to make the planet orbit vertically around the Sun? Pause the video now to think before I reveal the answer. To do this, you can simply switch the x and y components of your move command. By doing this, the planet stays at a point of 0 in the x direction and is animated in the y and z directions. The orbit is still circular because the two directions are animated with common spans and speeds, where one direction moves according to sine and the other cosine. Time for your final challenge. Create a 2.5D animation in the puppet show slot. If you need an idea, try making an aquatic ecosystem or a solar system. Remember to get help from the mentors if you need it. Thanks for sticking around until the end of the video.